Okay, so we're talking about action potential. So in your notes, so here's our action potential curve, okay? So we got our curve. So negative 60 millivolts is the resting potential. Our threshold potential is negative 40 millivolts. And then our peak on this particular wave is at plus 40 millivolts. Okay, so anything between negative 60 and negative 40 is what's considered threshold. So we can get some fluctuations here with action potentials coming in, but it has to reach negative 40 before we get the tidal wave, the all or nothing effect. Once we hit 40, it's going to go. We're going to reach peak. We're going to come back down, and then we're going to get back to our threshold again, our resting potential, and then we're just going to keep doing that as we move forward. Okay, so subthreshold, threshold, and then we come down here, and this is representative of a motor unit and a muscle. Okay, each individual box is a motor unit. So as this action potential comes down, a normal action potential of like plus 40 is going to come down, and it's going to activate the one motor unit or the one muscle fiber. If the action potential here is stronger, it gets stronger, we consider that submaximal, and that's going to start to spill over, and it's going to start to activate more motor units in that muscle. If we reach maximum potential or maximum effort, it's going to activate that whole muscle, and it's going to cause that whole muscle to contract. So those are the concepts that we have. The last concept is that if once we activate the whole muscle, the only way from that point on to increase the force of that muscle's contraction is to go and actually have more waves or more action potentials per unit of time. So in this case, I've got more action potential waves in the same time period than this one. So 1 would be a stronger force than 2 because the number of waves per time unit is more. There's more of them than down here. So here there's 1, 2, 3, 4, 5, 6, and that 1, 2, 3. This one's more powerful or more force.